In 2017, a strange visitor entered our solar system. It wasn't just another comet or asteroid, it was moving too fast on a path no object had ever taken before. Scientists named it Oumuamua, meaning first messenger in Hawaiian. And almost immediately, this cosmic traveler began to defy everything we thought we knew about physics. But here's the twist. By the time we noticed it, Oumuamua was already on its way out, racing back into deep space. With only a short window to observe, astronomers scrambled to collect data. What they found was so bizarre that some experts even considered one explanation few had dared to say out loud, alien technology. Today, we're diving deep into the mystery of Oumuamua. What exactly was this object? Why did it behave in ways no natural body should? And most importantly, are there more like it coming our way? Stay with me, because the story you're about to hear will change the way you think about our place in the universe. Before we dive deeper into the mystery, let's step back for a moment. What exactly is an interstellar object? In simple terms, it's a traveler that was born around another star, but somehow escaped its home and wandered across the galaxy until it crossed paths with our solar system. Scientists estimate that thousands of these visitors may pass near us every single day. Most go unnoticed, too small and too faint to detect. But every once in a while, one drifts close enough and bright enough that we finally catch a glimpse of it. That's why Oumuamua was so extraordinary. For the first time in history, we actually saw one of these cosmic drifters with our own eyes. To understand why scientists expected to see interstellar visitors, we need to look at the edge of our own solar system. Beyond Neptune lies the Kuiper Belt, a vast region of icy worlds, and even farther out is the Oort cloud, a giant sphere that may contain trillions of comets, all loosely bound to the sun's gravity. Most of the comets we see in the night sky likely come from this region, taking tens of thousands of years to complete a single orbit. But these fragile objects can be disturbed. The gravity of passing stars, even those several light years away, can tug at them, sending some comets plunging inward toward the sun, while flinging others completely out into interstellar space. If our solar system can lose and capture objects in this cosmic dance, then so can every other star. That means interstellar drifters like Oumuamua are not only possible, they are inevitable. On October 19th, 2017, astronomers at the Haleakala Observatory in Hawaii spotted something unusual. At first, it looked like a faint moving dot against the stars, nothing extraordinary. But when they calculated its trajectory, they realized this was no ordinary object. At first, it was classified as a comet, and then reclassified as an asteroid when no visible coma or tail could be seen. But even that label didn't fit. Its path showed it was moving too fast, on a hyperbolic orbit that would take it right out of the solar system. That was the moment scientists gave it a new name, Oumuamua Hawaiian for first distant messenger. It was the first confirmed interstellar object ever detected, and the clock was already ticking to study it before it vanished into the darkness. What made Oumuamua even more remarkable was its trajectory. Unlike planets, comets, or asteroids that orbit the sun in closed loops, this object was traveling on a hyperbolic path, an open curve that meant it wasn't bound to our solar system at all. In other words, it wasn't from here. It had come from deep interstellar space, passed close to the sun, and was already heading back out, never to return. This realization stunned astronomers. For the first time in history, we had solid evidence that a visitor from another star had crossed through our cosmic neighborhood. The mystery deepened when astronomers tried to determine its shape. Based on the way its brightness fluctuated every 7 hours, they concluded the object was rotating and reflecting sunlight in unusual patterns. The data suggested it could be long and cigar-shaped, or perhaps wide and flat like a saucer. What made things even stranger was that it wasn't spinning smoothly on a single axis. Instead, it was tumbling chaotically, as if it had been knocked around by some ancient collision. Whether cigar or saucer, natural or not, one thing was clear: Oumuamua didn't look like anything we'd ever seen drifting through space before. Just when astronomers thought they had seen it all, Oumuamua delivered its biggest surprise. As it passed closest to the Sun in September 2017, it was moving at a blistering 87 kilometers per second. But instead of slowing down as gravity should have dictated, it suddenly accelerated. The change was small, about 17 meters per second, but enough to send shockwaves through the scientific community. Nothing in our physics textbooks explained why a rock drifting through space would speed up on its own. To put it in perspective, imagine a sprinter suddenly finding an extra burst of energy mid-race, or a car speeding up without anyone pressing the gas. That was the puzzle of Oumuamua. Faced with this mystery, scientists searched for answers. Could the solar wind, the constant stream of charged particles from the Sun, have nudged Oumuamua forward? The math didn't add up. The force was far too weak to explain its acceleration. What about outgassing, the process that gives comets their tails? Normally, when ice turns to gas under the Sun's heat, it pushes the comet forward like a natural rocket engine. But astronomers couldn't detect any gas or dust coming from Oumuamua. The two most obvious explanations had failed. That left scientists with an even bigger question. If it wasn't the Sun's wind, and it wasn't outgassing, then what was pushing this interstellar visitor? To dig deeper, astronomers turned to the Spitzer Space Telescope. For 30 hours it stared at Oumuamua, searching for any trace of heat or gas. The result? Nothing. Not a single sign of outgassing appeared in the data. That was strange enough, but Spitzer also revealed something even more puzzling. Oumuamua reflected sunlight about 10 times more efficiently than a typical comet. It was unusually shiny, as if made of metal or coated in something smooth. Together, the lack of gas and the strange shine deepened the mystery. If it wasn't a comet, and it wasn't an asteroid, then what exactly was this object? With natural explanations falling short, some scientists began to consider more radical ideas. One of the loudest voices was Harvard professor Avi Loeb. He proposed that Oumuamua wasn't a rock at all, but an artificial object, a kind of light sail. Imagine an ultra-thin sheet, only fractions of a millimeter thick, built to catch solar radiation like a ship's sail catches the wind. If true, this would mean Oumuamua wasn't just the first interstellar visitor we detected, it could have been the first evidence of alien technology passing through our solar system. Not everyone agreed with Loeb's bold claim. Another group of scientists, led by Darryl Seligman at Cornell University, offered a different explanation. They suggested that Oumuamua might not be a light sail at all, but a strange kind of comet, a dark comet. Unlike normal comets, it wouldn't produce a visible tail. Instead, it could be releasing invisible hydrogen gas. Experiments have shown that ice exposed to cosmic radiation can trap tiny pockets of hydrogen. When warmed by the Sun, that hydrogen could escape, giving the comet a subtle push without leaving behind dust or light. The debate quickly turned into a scientific showdown. On one side was Avi Loeb, arguing that only an artificial light sail could explain the data. On the other was Darryl Seligman, convinced that invisible hydrogen outgassing was the answer. Loeb pushed back hard, claiming that a hydrogen iceberg couldn't survive the journey through interstellar space. It would evaporate long before reaching us. Seligman, however, refined his theory with the help of new lab results. Together with Jennifer Bergner, he argued that pockets of hydrogen trapped in ice could survive and release just enough thrust to match Oumuamua's odd acceleration. The mystery of Oumuamua sparked a wider search. If one object could behave this strangely, were there others? Astronomers combed through existing data and found 6 small bodies within our own solar system, showing unexplained acceleration just like Oumuamua. These weren't interstellar visitors, but near-Earth objects, tiny asteroids only a few meters across, close enough for potential missions. And intriguingly, one of them, known as 1998 KY26, is already scheduled for a spacecraft flyby. Japan's Hayabusa 2 probe, which already returned samples from another asteroid, is set to visit KY-26 in 2031. That mission could provide the first real test of whether dark comets exist right here in our cosmic backyard. Behind the data and debates, there were also people racing against time. One of them was Karen Meech, an astronomer at the University of Hawaii. She led the team that characterized Oumuamua after its discovery. By the time they spotted it, the object had already passed its closest approach to the Sunday. That left only about 40 days before it became too faint and fast to study. Meech described the effort as a frantic sprint astronomers around the world pointing every telescope they could at this disappearing messenger, desperate to capture as much information as possible before it was gone forever. Even as Oumuamua slipped away, some scientists began to wonder, what if we could chase it down? Out of that question came Project Lyra, an ambitious proposal to send a spacecraft after the interstellar visitor. The idea sounded like science fiction, but the team behind it argued it was technically possible. With the right trajectory and gravity assists, a probe could be launched to intercept Oumuamua even decades after its departure. It wouldn't be easy. The challenge was to reach incredible speeds, catch up across billions of kilometers, and still slow down enough to study the object once we got there. The first option proposed by Project Lyra was called the Solar Oberth Maneuver. The idea was bold: launch a spacecraft, swing it past Jupiter, and then dive close to the Sunday at that moment of maximum speed. Fire the engines to get the biggest possible boost. By using the sun's immense gravity as a slingshot, the probe could leave the solar system at over 70 kilometers per second, fast enough to catch up to Oumuamua. But this plan came with big challenges. A probe diving that close to the sun would need a heavy heat shield, and the extreme trajectory had never been attempted before. Technically possible, yes, but risky and untested. The second option from Project Lyra was less extreme, but still ambitious. Instead of diving dangerously close to the sun, the spacecraft would use a series of gravity assists from Earth, Venus, back to Earth, and then Jupiter to build up speed. This multi-step slingshot would launch the probe toward Oumuamua at a slower final speed, but with one big advantage: it would be easier to slow down once it arrived. According to mission planners, possible launch windows could open between 2030 and 2033, with an arrival at Oumuamua by 2048. While plans to chase Oumuamua remain on the drawing board, new technology is giving us fresh hope for the future: the Vera C. Rubin Observatory, set to begin operations in 2025, will be a game changer. With its massive telescope and decade-long sky survey, Rubin will be able to spot faint objects much earlier, up to 3 months before they pass by. Scientists estimate it could discover as many as 70 Oumuamua-like visitors every year, giving us plenty of chances to study the next interstellar messenger. Another exciting project on the horizon is ESA's Comet Interceptor, scheduled to launch in 2029. Unlike traditional missions with a fixed target, this probe will wait in space, ready to intercept the first suitable object that crosses its path. The probe will remain in a parking orbit for up to 3 years, conserving its resources until the right moment. When the target appears, whether a pristine comet or even an interstellar visitor, it will spring into action. Its instruments are designed to create a full 3D map of the object, giving us an unprecedented close-up look at something from the far reaches of our solar system or beyond. In the end, the question isn't just about science, it's about choice. Should we invest billions to chase a fading mystery across interstellar space, or wait patiently for the next visitor to arrive at our doorstep? For some researchers, the gamble is worth it. They argue that missions like Project Lyra could answer questions that change our place in the universe forever. Others believe the wiser path is to let Oumuamua go, trusting that the universe will send us many more messengers in time. Either way, the mystery remains taunting us with the possibility that the truth could be stranger than anything we've imagined. Perhaps the greatest mystery of Oumuamua is not what it was, but what it represents. A reminder that the universe is still full of surprises. Was it a comet, a dark iceberg, or a fragment of alien technology drifting silently between the stars? We may never know for sure. But maybe that's the beauty of it. Every unanswered question keeps our curiosity alive and pushes us to keep exploring.